Okay, so in this video, we'll be looking at parabolas with the vertex at 0, 0, the origin. Okay, so previously we've done graphing parabolas, solving using a quadratic equation, right? Those were more quadratic sense. Here we're just looking at the graphs, right? And we also dealt strictly with functions, and here you can clearly see this is not a function, so we're just looking at the graphs of parabolas, right? Whether they open to the side or left, right, or up, down. Right, so when they open to the left or right, like we have here, they have this general formula. Y squared is equal 4p times x. Right, and as we notice, in both of these cases, they have the axis of symmetry to be the x-axis. Now, we're also going to identify and label a couple of other pieces of information. Notice also here the way that we wrote the parabola equation. We wrote it as y squared equals 4px. Right. So a couple of others similar to our other conic sections. This parabola does have a focus, right? And that focus is going to be in the wherever it opens. So if it opens here, the focus will be somewhere here. Right? And where that is depends on the value of this value p, right? So the coordinate here would be p comma 0. Right. And another piece of information that we are going to identify, it's this vertical line here going through the focus, right, called the lattice rectum. So this right here, right, and then in this case here, the points here would be p, 2 absolute value p, and then down here p negative absolute value of 2p. All right, and depending on which direction it opens, so in this case, if it opens to the right, here the value of p is positive. And so we have a positive value here. All right, and again, here is the vertex at 0, 0. And we're also going to be identifying some line here that is behind the parabola, right? And this is called the directrix. And its equation is x is equal to negative p. All right, so here the distance between the vertex and the focus is the same distance, at least along the horizontal, to the directrix. All right. Okay, now if it opens the other way, right? So here what changes here is one thing is this corresponds with p being less than 0. Right? But the focus is still p0, right? So here's our focus. And we still, now in this case, our lattice rectum is the value here at p absolute value of 2p, right? So the coordinates, they're still the same, right? But in this case, the value of p is negative, so it'll correspond to the points that are on here, on this parabola that opens to the left, right? And this coordinate being p of 2p. Okay, and our directrix would be the line back here, x equals negative p, right, where this is our vertex at the origin. Okay, all right, so, excuse me, so here, I guess we'll label this directrix. All right, okay, so the directrix is the line. The lattice rectum is the line segment, all right? So it's not the full line. It's really just the line that is the vertical line going through the focus and the points that are on the parabola, right? So these represent the endpoints of our lattice rectum. Now, in a similar way, right, so this is one that opens left or right. If we look at one that opens up or down, then the same kind of properties hold, right? The only thing here that we notice here is, well, our equation now, right, this is something we're more familiar with. We just haven't written it in this form, but here the x variable is the one that is squared. Okay, so those same kind of, the same properties hold. In this case, the equation, or excuse me, the axis of symmetry is the y-axis. And so it's symmetrical across that axis. Right here, we're looking at still vertex at 0, 0. But now for something like this that opens upward, this is going to correspond to a positive p-value. Right, and now the directrix is going to be a horizontal line. X equals, or excuse me, since it's horizontal, y equals negative p. Right, so this is our directrix. Right, and our focus will be here, right? Coordinates will be 0, comma p. All right, so our focus is inside that parabola where it opens, and here we'll have the lattice rectum, the line segment going through the focus with its endpoints, in this case the horizontal line segment going through the focus with its endpoints on the parabola, right? And these coordinates, now we just flip around their position, right? Since we're looking at something that is essentially rotated 90 degrees. So this will be absolute value 2p, p, and on the other side, negative absolute value of 2p, comma, p. Okay, and those would be the parts of the parabola with p greater than 0. For p less than 0, the axis of symmetry doesn't change, so we still have the axis of symmetry to be the y-axis. And so what does flip is the positioning of the directrix. So the directrix is now right above the parabola here and having the equation y equals negative p. Okay, and again, this is still a positive value since we saying our p is less than 0, so negative and negative is a positive, right? And our focus is this value here, and that is 0, comma p. All right. And then our lattice rectum here would be the line segment going through the horizontal line segment going through the focus with its endpoints on the parabola, and those coordinates would be still the same coordinates, right? Kind of depending on what p is. All right. Okay, and again, this corresponds for p less than 0. This corresponds to p greater than 0. Right, and again, depending on what that value of p does, right, that will depend on how wide or how narrow something like this opens. Okay. All right. Okay, and in fact, let's take a look here. Yeah, let me set up a graph here. See, I'm doing this on the fly, so apologize for the delay here. So let's see. Okay. All right. So what we have here is a graph right here on Desmos, and let's just look at what the graph here. If we graph something like x squared equals to 4py. Right, and we'll add a slider for p, and we'll let the directrix, what was that, y equals to negative p, and our focus is 0, comma p. Okay, and then we could see as p gets larger in value, right, we could see the parabola open up, or excuse me, getting wider, I should say, right? And the focus goes further and further up, and the directrix goes further and further down, which makes sense, right? So the distance here between the focus and the directrix, and here, let's see, our lattice rectum are the points negative 2p, comma p, and then our other point is absolute value of 2p, comma p. Okay, all right, and here, let's see. Okay, all right, and then if we look at, let's look at positive, so those are positive values. You see as p gets smaller, right, those values start to bunch up, and as, here we go, when p gets negative, we see we have the flipped relationship, and as p gets negative, more negative in value, right, or smaller, right, we see the same kind of relationship, right, where the parabola opens up wider, and we get the focus and directrix getting further away from the vertex. Okay, thank you.